Well, as promised, my Algebros, I'm recording our video study guide for chapter 4, right? Okay, so we went over these in class, but I wanted to make sure you had a video to watch to review again, in case you wanted to download another video onto your iPad and do the practice problems again. Number 1 asks if this is a linear function. We know that 1, it's not a straight line, so we know it's not a linear function, but when I do the vertical line test and hold on to this line, I can see that it crosses the x values more than once, so x is cheating or repeating. So no, it's not even a function, let alone a linear function. On number 2, we can see there's a constant change in x and y values. X is not cheating or repeating. And the y values are also going up consecutively by 3. Because there is a constant change in both the x and y values, we know that the slope stays the same. It rises and it runs the same. Therefore, it is a linear function. On number 3, we see that this is a 0 slope, and that's because all the y values are repeating. If it was a vertical line, we would say that is undefined because all the x values are repeating. On number 4, this is a negative slope because we read lines from left to right, and we can see the end game is at the negative quadrant, making this a negative slope. On number 5, it asks us to make a t-table and solve for the x and y intercepts to graph, right? So that means if I want to solve for the x-intercept, y has to be 0. So I'll have 3x equals 36, and I divide and I get 12. And if x is 0, then it's negative 9y minus, 36 divided by 9 gives you negative 4. And you'd have your 2 good points where you could graph. Number 6 asks you to find for the x-intercept. That means that y is 0, goes away. So let's have negative 3x equals negative 27. Divide and solve and get x is 9. On number 7 and 8, it asks to identify the slope and the y-intercept in the given equation. So the slope is the number in front of the x. It does not include the x, so it's negative 3/7 for the m, and b, y-intercept is negative 8. On number 8, we see it's another 0 slope because all the values are negative 9 for the y. On number 9, it asks us to find the slope, so we need to have the slope formula. Make sure you memorize these, and then you can solve for the slope plugging in our points. Now, I like to label my points to make sure I don't make a mistake. So I do my y2 minus my y1 over my x minus 2 minus my x1, and I solve and get 10 over negative 3. If I chose to label the points oppositely, having the first point be the second point and the second point be the first point, then my slope would have been negative 10 over positive 3. But still, it's a negative 10/3 slope. Number 10, I solve and I get negative 5, which means it's a positive 7 over 5 because a negative divided by a negative is positive. The graph on the right, we need to identify the slope. I need to pick a point and then go to rise and run to the next point. So on this one, I chose the middle point. I'm going down 4 and over 5, where I'm running, I'm rising a negative 4 and I'm running a positive 5. So I could tell this is a negative slope, so I did this correctly. I could have taken the bottom point and gone up a positive 4 and then over a negative 5. Both are the same. And the y-intercept happens to be a 0. This is a direct variation equation of y equals negative 4/5 x. Now I could put plus 0 in there. I'm not going to get marked down for it, but I don't have to. All right, graphing. Number 14 is set up for us in y equals mx plus b. the star of the show for this chapter. So I want to identify how I'm going to do this. So I need a point and a slope. And so my slope is going to be 1/4, meaning going up 1 and to the right 4, because they're both positive numbers. And then my y-intercept, or my 1 point that I need, is going to be -2. So I start with the -2, and then I do the slope from there. Connect my dots with a perfect straight line using a ruler, and add my arrows. On number 15, I could solve this one of two ways. Firstly, I could go ahead and use x and y intercepts because they all divide so nicely. And if I do that, then I get y is 3 when x is 0, and x is -2 when y is 0. And I have my 2 good points to graph, right? I could also just solve for y. And if I choose to solve for y, I have to subtract the 3x from both sides and divide everything by -2. On this, I see that I would get y equals 3/2x plus 3. When I go to graph this, my y-intercept, I run out of room if I were to use that 3/2, right? If I'm going to go ahead and graph, I'm going to go up 1, 2, 3. Well, I'm off the graph, but that's okay because I can make it -3/2 because a negative divided by a negative is a positive. So I'm going to go ahead and go down 3 and over 2. When I do that, you can see I get to the same line, right? And number 16 is set up so that you can just divide everything by 3. You get y equals mx plus b. My slope is -1/3, and my y-intercept is 2. I know that with my slope, I'm going to be going down 1 and over a positive 3. Start with 2, down 1, over 3. And I draw my line, including my arrows. Of course, I could have done x and y intercepts. If I did that, I have to move the x value over so it's in standard form. And then I solve when y is 0, x is 6, and when x is 0, y is 2. Same points, same line. Number 17 gives me a point and a slope. And when I'm given a point and a slope, to get to that slope intercept y equals mx plus b star of the show, I use the point slope form to get there so I don't make a mistake, right? And then I go ahead and put in my point. I have a y1 and I have an x1 and I have a slope. Then I just evaluate for y, getting the equation of the line. For 18, I'm given 2 points, so I first need to use those 2 points and the slope formula to solve for my slope. So my slope is 2. Now I have a 2, and I chose to use the first point, so I put in for my slope point slope form, and I solve for the equation of my line. Now I could have used the other point. If I did that, you can see I also get the same line. It doesn't matter which way I decide to go. Now on the next question, I have a line and I need to first find a line that is parallel to this line but goes through the point of 8, -2, right? 8, -2, super important. So on the parallel line, I know it's the same slope. They have the same rise over run, but the perpendicular line has an opposite reciprocal slope. So I go ahead and use my point slope form to solve for my slope intercept form. And then the next equation, I do the same exact thing, but instead I'm using a different slope because I'm using an opposite reciprocal slope with the perpendicular slope. And I get y equals 1/4 x minus 4. And if you need that reminder of what the slope formula is, there you have it. All right, right, that brings us to the practice test. So I decided to give you a study guide and a practice test. Hopefully you completed the practice test already before you're checking your solutions. Number 1 asks if this is a linear function, and this is a review concept. We already have these kinds of questions, and we know yes. We check to see if there's a constant change in both the x and y values, and there are, so we know yes, it is a linear function. On number 2, we solve for x and y intercepts. I solve for x when y is 0, and I solve for y when x is 0. And I have my 2 x and y intercepts. X is 8 and y is -5. On number 3 and 4, again, we're given a slope-intercept form, and we need to say the parts of it. So number 1, when y equals 7, that's a 0 slope, and the y-intercept is 7, because all the y values are 7. And number 4, I have no y-intercept. Instead, I just have a slope of -7/4. Number 5 asks us to practice the slope formula, so I'm going to go ahead and do that again. And I'll write that on the side for you. And I want to reduce these. Just a reminder, if I can reduce a fraction, I'm going to. Not making it a mixed number, but just reduce the fraction. Now on number 6, this is a different kind of question. This is a direct variation question. So it says, as y varies directly with x, which is just telling you these numbers are proportionate. So I know it's always y over x, so I can fill in what I know. I know y is 12 and x is 10, and then I don't know y when x is 45, and I can cross multiply and solve for my y value, getting 54. Now I could also use my y x equals k, or k equals yx. That constant is the ratio between y and x. So it's 12 divided by 10, which is 1.2. Then I can take the x value and multiply it by 1.2 and get 54, solving for what the y value is as well. On number 7, we need to put the slope, and that's the rise over run. And because this is going up by 1 and over by 1, I can go ahead and just do it on the graph. But if these did not, I would have to use my slope formula to make sure I didn't make a mistake on what the actual values were between each point. So bottom line, what does this mean? It means 3 cups of flour per 2 pizzas. But we would say 1.5 cups per 1 pizza. All right, some class is starting to play Christmas music. Awesome. So now we have for graph on the right, we need to say what is the slope. So again, we take 1 point and we look at the rise over the run. So I know first that my y-intercept is 3, and I can see from that point to the next point, I'm going down 3 and over 2. And then I can write the equation of the line from there. Now we're practicing graphing again. On 9, it's in y equals mx plus b. So I identify my parts. My slope is -2/5, and my y-intercept is 3. So I know I start with 3 and I go down 2 and over 5, but I could have chose to go up 2 and over -5 as well. Same line. On number 10, it is tempting to do x and y intercepts here, but if I do this, when I go to find the x-intercept, I'm going to have to divide 25 by 10, giving me 2.5. I don't want to have decimals. So instead, I'm just going to divide off 5, getting my y equals mx plus b form, identifying my slope and my y-intercept, and graphing from there. On number 11, I can see I can solve for y by dividing off 4 and graphing from here, because I know my slope and my y-intercept. But I could have also chosen to use x and y intercepts here, right? Because I could put it in standard form, moving the 3 to the other side, and solve for my x and y intercepts, and found they are the same. Okay, number 12 asks for the parallel slope of these lines. And we know the parallel is always the same, so whatever the slope is for A, it's -4, it would stay A. -4. And then B, the slope is 1/5, so it would stay 1/5. On 13, we know a perpendicular slope is opposite reciprocal. So the opposite of positive is negative, right? So I have to think, if it's positive, it's going to become negative, and if it's negative, it's going to become positive. And the reciprocal just means it's literally a reciprocal, make it into a fraction if it's not. So letter A is going to be -4, and letter B is going to be 1/2. Now getting to practice how to put all these concepts together, questions 14 and 15. 14 asks us to write the slope-intercept form, the star of the show, y = mx + b, line for these 2 points. But I know I need a point and a slope. So I use my slope formula to first find the slope. And then I'm just going to pick one of these points and use my point-slope form. When I do this, I solve quickly for the equation of my line without error. On 15, it says it goes through this specific point, but it needs to be perpendicular to the given line. So we take the slope of the given line, -3, and we make it the opposite reciprocal, which would be 1/3. And now we have a point and a slope, so we use our point-slope form. We plug in our values, and we isolate y, getting the equation of the line that is perpendicular to that other line. Lastly, we have an application question for a taxi cab company which is charging $3 to ride in the cab, plus an additional $1.75 per mile. So that $1.75 is going to be our slope, because it rises and runs with every passing mile. It goes up $1.75. And we have the initial fee, or y-intercept, of 3. Now how much will it cost if we go for a 5-mile drive? Well, that's my x value. So I go ahead and solve for that, finding out it would cost me $11.75. Okay, happy testing. See you soon. Bye.